Good afternoon. My name is Min Lee. I'm working at ECS Department, Southern Taiwan University of Science and Technology. Today, I would like to share my experience about the application of open source software in education. This is the outline. First, we will discuss the need of open source software in ECS Department. And I would like to present my courses using open source software, which are SPICE, analysis and simulation, 3D modeling and faster prototyping, and Unix Linux operating system. Then we will have a simple conclusion. First, I would like to discuss the need of open source software in ECS department. I've been working in ECS department for 17 years, and I have facing software issues since my very first day serving in STUSD. Students in ECS department require a lot of professional software to do their homework or projects. We can find open source alternatives instead of expensive commercial software. These open source software provides not only powerful performance, but also legal to use in home school without having to worry about copyright issues. In this talk, I would like to introduce my courses lectured using open source software. The courses are as follows. The first course is SPICE analysis and simulation. The second course is 3D modeling and faster prototyping. And the third course is Unix Linux operating system. First, I would like to introduce the course of SPICE analysis and simulation. SPICE is an essential tool for all students who major in EE-related departments. It is a general-purpose electronic circuit simulator. Modern electronic design requires SPICE as a simulation tool to verify the correctness of the circuits we design. Commercial SPICE tools have a lot of restrictions, which is not very practical for entry-level students to use. Now let's discuss a little bit about commercial SPICE tool. Commercial SPICE tools are very powerful tools to run circuit simulation. Yet, they all possess some limitations. First, almost all commercial SPICE tools are protected by licenses, which means students are only allowed to use these tools on certain computers. They cannot run it on their own computers. Second, some commercial SPICE tools have the so-called student version. However, these versions have different levels of restrictions like limited circuit size or limited functions. Students can only use this student version to run very basic circuit simulation. In other words, they are not able to do a bigger project or bigger homework. Third, commercial SPICE tools are all very expensive for all of us to purchase. So, this makes me wonder, is there an alternative to the commercial SPICE tool? What we need in the class. In order to teach students to learn how to run circuit simulation, we need two tools, Xcircuit and NGSpice. Before I discuss Xcircuit and NGSpice, I would like to present you the full custom design flow. This is the full custom design flow. When a student wants to design a chip, first he needs to use schematic capture software. For example, if you use commercial software like Synopsys Laker ADP or Cadence Composer, you can use these two tools to create schematic. Then you can draw symbol. After you create a schematic, you can use commercial simulation tools like Synopsys NGSpice or Cadence Spectrum to run simulation. After you run simulation, you can use Synopsys Cosmos Scope or Cadence Analog Environment to view the waveform. This is the very beginning of schematic capture and the SPICE simulation. Okay, so if we want to use open source alternative, XCircuit is a schematic capture software. It allows us to create a circuit and export it to SPICE format, or what we call the netlist. Then we can use the netlist to simulate using NGSpice. NGSpice is a circuit simulator to run the simulation. It can use the netlist generated by XCircuit to run simulation. This is the XCircuit website. It is used to create a drawing or circuit. Okay, now I have an example for you to show how XCircuit is used. This is an inverter circuit. You can assign the width and the length of a PMOS and NMOS. You can use VPOS as input signal and run output. The netlist generated by XCircuit is like this. It is very resemble to the commercial SPICE tool. And we can modify the XCircuit generated netlist to be able to run simulation. Now, I can show you how to run simulation. The SPICE file we have is inv.sp, so we can use ngspice inv.sp to run simulation. And when you press enter, the simulation result is shown in this window. The input signal is drawn in red line and the output signal is drawn in blue line. If you want to see these signals one by one, you can use plot v-in to see the input signal, and you can use plot v-out to see the output signal. Okay, NGSpice is an open source SPICE simulator for electric and electronic circuits. It has the following advantages. First, it is free to use, no limitations. Second, the SPICE syntax in NGSpice is almost identical to the commercial SPICE tools. Third, the simulation result of NGSpice is very similar to that of commercial SPICE tools. In short, students who use NGSpice to learn circuit simulation can transfer to commercial SPICE tools in the future when needed, which means one day when they have to do real chip and when they have to use real commercial SPICE tool like HSpice, they can transfer from NGSpice to HSpice without any problem. Now I will present you a few examples to show the difference of NGSpice and HSpice. Since in the beginning I use NGSpice, many people have asked me one question. How accurate is NGSpice simulated? Okay, what is the difference between NGSpice and HSpice? So I make a few examples to compare the different result between NGSpice and HSpice. First is the inverter circuit. This is the schematic create using XCircuit, like I have just shown you. And this is the simulation comparison. This one is the input signal, and this one is the output signal. As you can see, HSpice is the solid line, and the NGSpice is the dotted line. And the difference between HSpice output and NGSpice output is almost very identical. Okay. The second circuit I would like to show you is a NAND gate circuit. This is the schematic. And since it has two inputs, the input A and the input B is like this, and the output is present here. As we can see that the output from HSpice and the output from NGSpice is also very similar. The third circuit I would like to show you is a NOR gate circuit. This is the schematic, and this is the output. You can find that HSpice and NGSpice are also very identical. So we can say that NGSpice present a very accurate simulation result like HSpice. There are other examples I have used in my course, and I will present another one like bridge rectifier. This is the circuit of a bridge rectifier, and this is the simulation result. Okay, so by using X circuit and NGSpice, we can use these two open source software to teach students how to run spice analysis and simulation. The next course I would like to present is 3D modeling and faster prototyping. First, I would like to show you why you need the 3D print technology. It is necessary to design mechanical architectures when building robots, unmanned vehicles, or other projects. 3D printer technology is a fast budget way to create a prototype. It is possible to put a verified 3D model into massive production. Students in computer, electronics, electronical related areas all need to learn 3D print technology now. For example, this is one of the projects created by my student. This is a two-wheel balance car. As you can see, the material required in this project, you cannot purchase it on the market. So you need to customize these parts and print it using 3D printer. Then you assemble your 3D model with a circuit board, batteries, and motors to make it a real two-wheel balance robot. Okay, my course is 3D modeling and faster prototyping. So now I would like to introduce faster prototype process. Normally we use FreeCAD as a 3D modeling software. However, someone would use Fusion 360 to do 3D model. Then it can export .stl files. Then it will go to 3D printer or go to CNC. If you want to print it, use a 3D printer. You can use 3D slice tools like Cura to slice it and generate G code. Then we can use 3D printer to print this model. Or if you want to use CNC to create this model, you can use CAM tools like BlenderCam, PyCam, Fusion 360, or other commercial CAM tools to generate G code. CNC will use this G code to generate 3D models. Next, I would like to discuss about 3D modeling process. First, we use 3D modeling software like FreeCAD to create a 3D model. And then we use a G code generator like Cura to generate a G code. And then we use 3D printer to print the software, and then the whole process will be complete. FreeCAD is a free and open source, general purpose, parametric 3D computer aided design modeler with a lot of capabilities. Its official website is over here. Here we have a simple model like this. We can create a model like this. Then this is the dimension. This is the original drawing of this model. Okay, so we can create a model like this. Then we can use a 3D printer to print this model. Okay. By using FreeCAD, we can create different models like a table, like a chair, like this one, or this one, or this one. And we can also create parts, okay, such as this model. This model has different parts, like this one, okay. Okay, it has total of 9 parts, and we can use all these parts to assemble a model like this. Okay, so this is the model I just demonstrate in my slide, like this one, and then we can create a model like this one. This is also an assembled model. Okay, this is another simple model. This is a curved pipe model. This is not easy to build. And this is another simple model. Once you can create this model, you can use 3D printer to realize it. So, we can discuss the pros and cons of FreeCAD. First is that FreeCAD is open source, free software. Thus, the people are free to use. You don't have to pay for this. You don't have to pay any company. And the FreeCAD is very easy to use. Inexperienced student can learn FreeCAD to do basic modeling in 1 semester. Okay, in my experience, my student can create this model during this experience. From nothing to this model is just 1 semester. And it has versatile capabilities like modeling, assembling, FEM analysis, or BIM. And FreeCAD has a very active community. There are many teaching videos on YouTube and discussions in the official forum. FreeCAD also supports multiple OS platforms. It supports Windows 32, 64-bit platform, Linux, and Mac OS. And it also supports multiple file formats like STL, OBJ, and a lot of file formats. Okay, so what's the disadvantages of FreeCAD? FreeCAD is still in development. Thus, FreeCAD might crash during modeling. So you need to save your model over. And it has fillet bugs. Some fillet will not be generated correctly. And since this is open source free software, FreeCAD has no custom support, no guarantee. You are on your own. I also have created a series of tutorial video about FreeCAD. If you like to see my video, you can go to my YouTube channel and see how these tools are created. Last but not least, I would like to introduce Unix Linux operating system. Linux operating system is perhaps the most famous open source software. It is widely used in servers and embedded systems. Linux is so important for EE, CSE students to learn. I have uploaded this course to my YouTube channel. The link of the first class is here. The online course has been awarded as the OCW Excellence Award by Taiwan Open Course Education Consortium this year. If you are interested in my course, you can go to this website. However, I'm sorry that the language I use is in Chinese, not in English. Okay, now we can have a simple conclusion. Commercial software is just too expensive and has too many restrictions for students to learn. Open source software provides a reliable alternative instead of commercial software. Open source software is also productive enough for students to learn and doing their project. I think you should try it. It is good for everybody. You can get benefit from open source software. That's all of my talk. Thank you.